Welcome to the updated analysis of the Battery Energy Storage Systems BESS market for May 2025. In this white paper, we'll analyze the main technological developments, global market trends, and key specifications from the most relevant manufacturers. All of this with an analytical approach aimed at engineers and technical managers developing or evaluating large-scale hybrid photovoltaic projects with storage. Let's get started. In this report, we will discuss the following 12 slides, which structure the technical analysis of the BESS market, updated through May 2025. We will begin with a conceptual introduction to the battery storage system, followed by the current landscape with the most recent growth, installation, and capex data. We will then delve into the three main manufacturers, Tesla, BYD, and CATL, with specific sections where we will analyze their most advanced offerings, Megapack 2025, Cube-T ESS, and the innovative Tener Stack. We will also include a section for other prominent competitors in the sector, such as Fluence, Sungrow, Howen, and Wärtsilä, which are showing significant progress. We will continue with a technical and efficiency comparison between the main systems on the market, followed by a section specializing in cooling and safety, critical aspects for utility-scale projects. We will dedicate an entire section to the integration of BESSes in photovoltaic plants, analyzing DC and AC configurations, use cases such as arbitrage or firm capacity, and the impact on LSO. We will conclude with a detailed economic analysis and a series of practical implementation recommendations for engineers planning new hybrid projects. Let's start with the basics. What is a BESS system? BESS stands for Battery Energy Storage System, a battery-based energy storage system. Its main function is to capture electrical energy, generally from renewable sources such as solar or wind, to store it, and later release it when the grid needs it. This helps stabilize the electrical system, offer ancillary services, and intelligently manage the variability of renewable generation. So, why is this market growing so rapidly? There are four key drivers. First, the integration of renewables. The more solar and wind power penetrates the grid, the more necessary is a system that manages their intermittency in a scalable way. Second, grid resilience. Storage makes it possible to offer instant backup and stability services that until now have only been provided by conventional thermal power plants. Third, falling costs. Since 2020, BESS capex has dropped by 45%, making the LCOE of these solutions increasingly competitive. And fourth, an increasingly favorable regulatory environment with incentives and regulations explicitly promoting large-scale storage installation. According to projections for 2025, the global BESS market will reach $8.68 billion, with new deployments between 48 and 57 gigawatt-hours this year, an average cost of $105 per kWh, and a compound annual growth rate of 26% through 2030. Projected installed capacity for that year exceeds 170 gigawatts. Storage is no longer an option. It is a structural component of any modern energy strategy. We now look at the current state of the global BESS market in 2025. First, we see a 76% year-over-year growth in new deployments, reflecting the definitive acceleration of this technology as a structural energy solution. Projected installations for 2025 reach 69 gigawatts, representing a total cumulative capacity of 169 GW. Added to this is a key fact for project developers and engineers. Capex has been reduced by 20% in the last half of the year alone, driven by improvements in energy density, container standardization, and economies of scale. The central graph shows installed and projected capacity by region. China leads the growth, followed by North America and Europe. Meanwhile, regions such as MENA and Asia-Pacific are beginning to take off with solid short-term projections. There are four key trends for 2025. Accelerated hybridization. 62% of new utility-scale photovoltaic projects now include an integrated BESS system. Long-duration storage. The use of configurations with more than 6 hours of autonomy is skyrocketing, already exceeding 85% in new installations. Improvements in energy density. A 44% increase has been recorded compared to 2024, reaching levels of around 430 VHL in leading solutions such as the Tener Stack. Integration with artificial intelligence. The new BESS systems incorporate advanced energy prediction and optimization algorithms. Regarding the most significant recent milestones in the last half of the year, we highlight Saudi Arabia awards a mega contract to BYD for 12.5 GWh. CATL launches its Tener Stack with record density. Powen presents the POD Max in a 20-foot container format. Fluence completes a 900 MWh project in Poland. Trina Solar awards 120 MW in the United Kingdom. And Wärtsilä is reorganizing its strategy to focus exclusively on energy storage. Finally, in the lower right corner, we see the global market share of BESS manufacturers in 2025. CATL, BYD, and Tesla lead the way, followed by Fluence, LG Energy, Powen, and Sungrow, in a market that is experiencing rapid consolidation. All of this data makes it clear that storage is no longer an add-on, but a core strategic component in any large-scale photovoltaic development. In this section, we compare the world's leading BESS system manufacturers based on their production capacity, market share, and technological strategy. CATL leads the ranking with an annual production capacity of 30 gigawatt-hours and an 18% market share. It stands out for its record-breaking energy density, reaching 430 VHL with its 565 AHLFP cells. BYD ranks second with 24 GWh and a 16% market share, based on a strategy based on its proprietary blade battery LFP chemistry, designed for high durability and greater thermal safety. Tesla follows with 22 GWh and a 14% market share. Its strategy is full vertical integration, from manufacturing to the deployment of solutions such as the Megapack 2025, which has improved its energy density by 15%. Fluence, with a capacity of less than 12 GWh year, specializes in energy optimization software with its Fluence OS platform and solutions such as the 900 MWh contract in Poland. Finally, LG Energy produces 15 GWh year and is committed to local manufacturing in the US and Europe, strengthening its position in regulated markets. In the lower left corner, the positioning chart combines two key variables: manufacturing capacity and technological innovation. CATL and BYD are at the top of the chart, followed by Tesla and Fluence, each with differentiated offerings. Regarding strategic trends for the 2025 to 2026 period, 5 key drivers stand out. 1. Market consolidation, through mergers and acquisitions to secure supply chains. 2. Localization of production, to comply with local regulations and reduce logistical risks. 3. Software as a differentiator, increasingly important for management, optimization, and diagnostics of BESS systems. 4. Vertical integration. Manufacturers not only sell batteries, but also assume control of their design, operation, and maintenance. 5. Application specificity, solutions specifically designed for utility scale, industrial, or residential self-consumption. These trends will shape the technical and commercial decisions for upcoming large-scale storage projects. We now enter the technical analysis of the Tesla Megapack 2025, one of the most established solutions for large-scale storage. This system uses Li-ion NMC battery technology and offers a capacity of 3.9 MWh per unit, with a continuous power output of 1.9 MW. Its compact dimensions of 7.25 x 2.50 x 1.64 meters and a weight of 38 tons, making it a scalable module that can be easily integrated into container-type projects. Regarding efficiency and durability, the system guarantees a round-trip efficiency of 87%, more than 6,000 certified cycles, and an estimated lifespan of 20 years. Thermally, it incorporates advanced liquid cooling with segmented thermal control, a temperature tolerance of −2°C, and dual redundant circuitry, ideal for maintaining operational stability in harsh environments. In terms of safety, it integrates an early detection system with temperature and gas sensors, 24/7 monitoring, and automatic extinguishing activation in the event of a thermal incident. It also includes thermal insulation between modules to limit heat propagation, a key aspect in multi-container designs. At the regulatory level, it complies with UL 9540A, the critical standard for thermal propagation in utility-scale installations, as well as with IEC 62933 and NFPA 855, ensuring international compatibility in demanding projects. The main improvements compared to the 2024 version are as follows: 15% greater energy density, 30% reduction in installation time, thanks to quick connectors. Improved remote interface with advanced diagnostics. And a new robust configuration for extreme climates, operating from -30 degrees Celsius to +50 degrees C. The estimated price is $1.47 million per unit, with deliveries expected in the last quarter of 2025. Overall, the 2025 Megapack cements Tesla as a solid choice for developers looking for a balance of performance, scalability, and technical reliability